In this video, you will understand that functional application means a function applied to its arguments, and know what is meant by partial function application. Function application refers to applying a function to its arguments to produce a result. It's like calling a function with specific values. Imagine a function add that takes two numbers and returns the sum. So add xy equals x plus y. Function application occurs when we use this with actual values, actual numbers. So sum equals add 3, 5. Add is applied to 3 and 5, and the result is 8. The function effectively takes the inputs 3 and 5, performs the calculation 3 plus 5, and returns the value 8. This is a pure function application because it only computes the result based on the inputs without causing any side effects. Function application, therefore, is the process of giving inputs to a function. Function applications apply or call the function by using its name, followed by the arguments it needs, separated with spaces. So on the top left yellow box here, we see an example of the function without values, add 3 ints, x, y, z, equals the operation x plus y plus z. On the right yellow box, we see an example of a specific function application using 3 values. So add 3 ints, and we're supplying 6, 2, and 5. The green box down the bottom there is showing you the actual syntax that we could use to declare, or in other words, set up this function in the functional programming language Haskell. And we're going to be looking at that in more detail in later videos. For now, you don't need to worry too much about the syntax being shown there. Now, here's an interesting statement. Every function, that's every function in functional programming, takes only one argument. But how can this be true? Given the example that we're literally looking at now clearly shows that add 3 ints takes in 3 integers as inputs and returns 1 integer as output. It seems like those two statements are conflicting. Well, there in the top box is an example of a function declaration for add 3 ints. This is going to set up the function we can use. And we can see we've got integer, and then we've got this arrow symbol, integer, integer, integer. One of those is the return values, and the other 3 are the inputs. Well, this is actually the same if we use brackets, which gives us precedence, as saying we have a return value integer that takes in 1 input, and that's the outer set of brackets. And then it can evaluate the internal sets of brackets separately and return the values, so that each time we return something, add 3 ints is only taking in 1 input. So let's just show you exactly what I mean. So we have add 3 ints and we're supplying it 625. But remember the statement, a function could only take in 1 input. So because of this use of brackets, the first bit we do is we add y. And this is the only value we're adding, and we add y to 6. We can then evaluate the inner bit. So now we've got 6 plus the 2, that's already been calculated. So now we're taking in a single output, and we add z. Z is now our only input, and we add it to the previous value of 8. And of course, we carry on. And we end up with our total 13. Partial function application takes advantage of what we've literally just shown you. It's the concept of taking a function that accepts multiple arguments and creating a new function by fixing some of those arguments. The new function then requires fewer arguments to be called. It's like setting up default values for a function ahead of time. Here's a very simple example in JavaScript. So you have a function that adds 2 numbers, add bracket a, comma, b, close bracket. Using partial function application, you can create a new function that fixes the first argument, let's say to 2, and only requires the second argument. Add2 is a new function that always adds 2 to whatever number we pass to it. In this example, add2 is a partially applied function of add, with the first argument fixed to the value 2. Add2 could be more convenient if we know we'll frequently be adding 2 to different numbers, as a specific use of a more general add function. This way, we can create specialized functions based on more general ones without repeating any code. Another way to think of partial function application is that it is the process of decomposing or breaking apart multi-argument functions into smaller functions with fewer arguments. So we have the following function, sum integer, integer, integer. And remember, one of those is the return value and 2 are the inputs. Now let's say we call the function as follows, sum5. Now this would result in an error as the function wanted 2 arguments. However, we can use this partially applied function as an argument to a separate function. Partial application results in us fixing, or what we call binding, the value of some of the inputs, in this case just one of them, to a function to produce another, more specific function. We can use this new function and it will add 5. Having watched this video, you should be able to answer the following key questions. What is function application? And what is partial function application?